maximum profit here is 8, right? So what we will be doing, we will be adding this particular weight, that is 1, that is item number 5, into our knapsack, and weight of that is 1. So our maximum weight for this is 10, I think 10 kg. So we'll see that. I'm just giving an. So we keep on adding the items into the knapsack without exceeding the limit of the knapsack. Right. If the knapsack can still store some weight, but the weights of other items exceed the limit, the fractional part of the next item can be added. So what they are saying, if you keep on adding without exceeding the limit, and in the end, if you still have some weight to be added in the knapsack, but the weights of the items are exceeding the limit of your knapsack, then you have to you need to add the fractional part of the next knapsack. So you have to add the fractional part now, hence giving it the name fractional knapsack problem, right? So this is your algorithm basically. And for example, like here we are given the set of items and the knapsack capacity is of 10 kg, and you have to find the subset of the items to be added in the knapsack such that the profit is maximum, right? So you have item 1, 2, 3, 4, 5 item, and weights of that item is given. 1 is 3, 2 is 3, 3 is 2, 4 is 5, and 5 is 1. These are the weights of these items. The numbering is given for the items. Then you have profits. So first item as 10 as profit, second as 15, third as 10, fourth is 12, 5 is 8. These are the profits, right? So step one says that you have to calculate PI divided by WI of all the items. That is profit divided by the weight, right? So number of items are 5. Your n is 5. Your number of items are 5. Your weight WI array will be 33251. So the weights array is this, and the PI, that is profits array, is this. These are the values of the profit array. So these you have to take in your program when we'll implement it. We write a program, right? Now you have to calculate PI divided by WI for all the items. So you have to keep an array again for keeping these items profit divided by weight. You have to again take an array for that to keep the division in that. So you will divide 10 divided by 3, 15 divided by 3, 10 divided by 2, 20 divided by 5, 8 divided by 1. So these are the values you get for PI divided by WI, profit divided by the weight. Now you have to arrange all the items in descending order based on PI divided by WI. That means this PI divided by WI array has to be arranged in descending order. So you will arrange these items in descending order. Sorting, you have to sort them. So you will use a sorting process in that. So you sorted, the highest profit is of item number 5, right? Then 2, then 3, then 4, then 1. These are the numberings which have been changed. So these are the profit. So maximum is this one, maximum profit. Now the next step is, without exceeding the limit of the knapsack, insert the items in the knapsack with maximum profit. So first item which we add in the knapsack is 5, right? And our weight of that item is 1. Right. So weight of the item is 1. We have put in the knapsack, right? And the profit of that item is 8, right? Okay, fine. Then we are left with 9 kg now, right? So we will put next item will be item number 2, which is having a weight of 3. So the weight is 3, right? So we in the knapsack we will be keeping that we have taken the whole of item number 5, we have taken the whole of item number 3, that is 1 1. We have taken the whole of item number 3 also. So if you see here, 1 has been the what items have been taken whole, you will keep 1 in the knapsack, and what items you are keeping fractional part, you will say the fraction of that item. So let us see. So first we have kept 5, that is weight 1. then we have kept 2, that is weight 3. So now we are left with 3 plus 4, we are left with 6 kg, right? Then we take third item, which has the maximum profit, then that becomes 4, 5, 6, 6 kg has been put. So now you are left with 4 kg, right? So if you are left with 4 kg, right, which item you will keep now? So, however, the knapsack can still hold 4 kg weight, but the next item having 5 kg weight will exceed the capacity. If you see, the next which is having the maximum profit is this one, which is having 5 kg weight, and you are left with 4 kg in the knapsack. So therefore, only 4 kg weight of the 5 kg will be added in the knapsack. So you have the weight of that item is 5 kg, but you can only add 4 kg. So we will use a fraction of that part, and that means 4 by 5, 4 divided by 5, right? So this we have taken whole first, this and this we have taken, but for this we are taking the fractional part. Right. So now, hence, now your knapsack is full, right? Now you cannot put anything in that. Hence, the knapsack holds the weight. So how to calculate the knapsack weight is, for this is knapsack has whole one, this whole item. So 1 into the weight of the item is 1, plus 1 into the whole item 1 into 3 the weight, plus 1 into 2 the weight, and plus 4 by 5 into 5 the weight of that item is equal to 10. The total weight of the item you need to keep in your knapsack is 10 kg, so that you have achieved with the maximum profit of. Now, how to calculate the profit? 1 into 8, right, plus 1 into 15, plus 1 into 10, plus 4 by 5 into 20, which is coming out to be 37. Right. So this was exactly your knapsack problem, fractional knapsack problem. This question will probably will come in your theory exam also, right? So this is what your algorithm is, and this is how you solve the knapsack problem. Right. Now, how they have implemented in the C program. So that is what we are seeing. So here they have. I have told you you have to take the number of items n is equal to 5. I told you that you have to take the profit and weight arrays. So profit array is this, weight array is this. They have taken 10 as the size, and they have assigned these values which was given in your question. Then int w is equal to 10, that is knapsack. This w represent the knapsack variable. So w is equal to 10 kg, the maximum weight which you are taking. So these we have defined before the main. So these are your global variables now, right? Now inside the main we are saying int current weight. For current weight we have taken a variable float total total we are another variable we are taking float int I and max I. These also we are taking as variables. Int used 10. So this is another array we have created with size 10, which is used, right? Now for I is equal to 0, I less than n, because n number of items which are there is 5, right? I less than n, I plus I, if used I is equal to 0. So your used I, where was it? Sorry, you used I is equal to 0. Initially we have set in the for loop. So all the 10 indexes will have 0 value in your array. For I is equal to 0, I less than n, plus I, used I is equal to 0. So all the in the array, all the indexes will have 0, initialized to 0. Then current underscore w is equal to w. That means your maximum weight you are set putting it in the current weight or current weight right now. Then while current weight is greater than 0, so until your current weight is greater than 0, what you have to do, max I is equal to -1. So maximum you are setting it to -1 initially, right? For I is equal to 0, I less than n, plus plus I, again a for loop you are applying. If used I is equal to 0 and max I is equal to -1, or float wi divided by pi is greater than float w max I divided by p max I. So here we are checking that our wi, this index uh, divided by pi. I think it should be pi divided by wi. Let's see. So wi divided by pi is greater than float w max I divided by pi. So they are checking whether the weight is greater than the maximum value, maximum index you have set. So right now the maximum index max I is -1. So they are checking which one is greater. So we are saying if this is 0 and this is -1 and float wi divided by pi is greater than this, then you are setting max I as I, that index, right? Used max I is equal to 1. So the in the index number 1, so the first index of the used array, you are putting 1, right? Then current underscore w is minus p max I. So you are subtracting from the weight, current weight, which is your 10 kg, right? You are subtracting the p max I, that is okay. They have p, they are representing the weights, and w they are representing the profits. They have I think used different symbols. So P they are using for the weights and W they are using for the profits. That's why here they are saying profit divided by the weight, WI divided by PI. That's why. Right, so they are using that. So WI divided by PR, we are checking whether this one is greater. The weight divided by PI is greater than W max I, or so we are setting that first. You set the max I as the first index, and use max I, that is the first index in the used array, will be set to 1, right? And current weight minus P max I. So you will from the current weight you will subtract the weight which you are selecting for P max I, which will be, I think, this one, the first one. So this will be subtracted. So now current weight is 9 kg according to this, right? And total underscore V plus is equal to W max I. And total, you are adding the weight in this total V, the profit, sorry, the profit in total V, you are adding the profit one by one. If current weight, right? So this I think, okay, this is also inside while only. If current weight is greater than equal to 0, printf added object percentage d percentage completely in the bag, space left percentage d max I plus 1, blue max I p max I current weight. Else printf added percentage weight object percentage in the bag int I plus float current weight divided by p max I into 100, and total weight minus is equal to w max I, total weight plus is equal to, because right now our current weight is greater than 0, so it will show, like here they are saying added object 5. So they are saying printf added object percentage d percentage completely in the bag, so space left percentage d. So when you are saying added object percentage d completely in the bag, and you are printing first added object percentage d max I plus 1, right? So here they are saying object added object 5, right? And inside the bracket percentage d are w max I, so the profit of that item, comma the weight of that item p max I. Index number will be the 0, completely in the bag, and space left is, because we have subtracted from the current weight, the space left is 9 kg, right? So again it will go back here to our to our for loop. Here it comes back, sorry, while loop. Here it comes back, and again current weight is 9 kg, which is greater than 0. Again your max I is set to -1. If I is equal to 0, I less than n, I plus I. If used I is equal to 0 and max I is this and this divided by this, then max I is equal to I you will set, right? So this all the items will be checked. All the items will be checked in this. Which one is having the maximum weight divided by profit? So all the items will be checked, and then that index will be set to I, right? And in the used, you will set it to 1, that this whole item has been used, and you will subtract the current weight from the maximum weight. The weight will be subtracted with whatever weight you have used from the current your total weight, and the profit is added in TV. So you are doing that. So then second object is added completely. It will say item object 2 is completely added, right? Which is having weight, profit of 15 and weight of 3, and space left is 6, right? Then third is added, then 1 is added, right? Now added so now they are saying your added, but now printf, if your current weight is not greater than not greater than or equal to 0, then it will come here, and it will say added percentage d percentage of the, so two percentages have been added to represent here percentage symbol of the object percentage in the bag. So how they are calculating the percentage is int, they this is typecasting they are doing, int, then 1 plus float, right? Current weight divided by p max I into 100. So current weight is your the weight which is left divided by the weight of the item into 100. So current weight is left was uh, uh, 4, and your p maximum was 5. So current weight divided by 5 into 100 will give you the 19%. That means whatever percent comes out, so that percentage is being printed with the weight and the profit of the item and of the object 4 in the bag. Object 4 is added. This much percentage of object 4 is added in the bag, right? So this is what you have done. Now you are saying printf fill the bag with objects worth percentage dot 2f, 2 decimal places float values total v. So filled in the bag with objects worth 45.40. This is what is being calculated. You can simply according to your own thing also you can calculate this thing, right? If we take, just giving you an example, right, this was our answer. Now, if we take one of our things, so we have 15, 5, 20, 15, 5, 20, 8, 7, 26. 8, 7. These are the values 20 and 6. Sorry, 20 and 6. So these are the profits, and 3, 4, 6, 8. 3, 4, 6, 8, 2, 2, 3. 2, 2, 3. These are your weights, right? Profit and weight. And maximum capacity is 18, right? So this, again, this program, we are taking the weights, and the number of items are 1, 2, 3, 4, 5, 6, 7. 7 items are there, right? So number of items we have taken 7. Okay, so now if we run it, so they are saying added object 6 first, completely in the bag. Left is 16 because the weight of that item is 2, profit is 20. Then the next object which is added is 1, which is profit of 15 and weight of 3. So the left is weight is 13. Then next is 5, which is 11. Then 3, which is 5. Then 7, with left with 2. Now the next item which is there is second, which is having a weight of 4, and we are left with 2. So 2 divided by 4, which is we are having 50% of the object is added in the object number 2 is added 50% in the knapsack. Total fill the bag with objects worth this much. You can also use the what is that? Print the filled the used array, or what all things have been added in the used array. So you can also print that and see. I'm just seeing that. these are the values which are here. It is not the sixth item they are taking is 50%, but they have taken as whole. For the fractional part, they have to see that if it is fraction, then what has to be saved here. So from this, you have to, according to the total V's formula, 1 plus current weight divided by P max into the our formula says 1 into. We have to change this a somewhat different way because we have to capture this 1, multiply it with the this way, multiply it with the profit, plus next which is whole 1, then multiply with the profit. So this way we have to do. The formula for total weight, according to me, I think here it should be not like this. It should be used I multiplied by WI. This should be there. Used I multiplied by WI. The sum of that. And this one will be this into 20. And there should not be anything 1 plus, I think. Something else is coming on. Now something else is coming in. It's some other program also, but this is how basically this is what the thing is. We'll see some other program also if we get an idea. So what they are doing is step one is calculate the ratio profit divided by weight for each item. So if we see here, so here what they are doing is they have taken two functions. This is actually sorting the items. So compare function to sort items based on the value divided by weight ratio. So here profit and weight, so compare A comma B, right? They are passing. So where that function is being called. Are you seeing the compare function being called anywhere? I think so. It is required actually. You can instead of doing this, you can also make your own program. Now what you will follow is first you will calculate the ratio profit divided by weight for each item. right? So you are taking one array. You like here we have taken one array for weight and one array for profit. You can take another array which will be keeping the weight divided by profit divided by weight. Those the values of profit divided by weight will be kept in that array, right? And now you will start sorting the array in decreasing order. Sort that array in decreasing order, and then you will apply the you will check whether the the array's item, right, uh, according to the weight that item is another array you will keep is used, right? So you will be keeping the particular item with the maximum profit divided by weight, right? You will be selecting that, and the weight will be deducted according to that. So here you are deducting the weight, the from the current weight you are deducting the weight according to that, and you are adding uh, multiplying the profit with the whole weight 1 into. So you have to multiply 1 into that. So that thing you have to do. You can also make your own thing also if you want. I want. Is there any other question? Any other implementation given? So here what they have made a structure of item, and they are saying int value, int weight, right? Structure they have taken. Now they have made a class solution in that in they are making a public static comparison. The boolean is the bool is the data type of that. That means it will return true or false. So they are taking item A, item B, two items they are taking, and double R1 they are taking a variable where they are saying double of A dot value divided by double A dot weight, because we have set value and weight as int, right? So A dot value divided by A dot weight, that means value and weight are added of that item, divided, profit and weight are divided, and again R2 B dot value is divided by B dot weight, right? So second item's value are divided, right? If and then you are returning R1 is greater than R2, right? So you return R1 is greater than R2, so you will return that. Then double fractional knapsack, you are making a function in W, item ARR array you have created. Item is the structure, and the structure array you are creating here. This is a structure array variable you are creating. Int n you are passing. Sort ARR plus n comp. So sort anywhere they have made a sort function. Compared to it is there. Where is sort? They have said current weight is equal to 0, final value is 0.0. Two variable they have taken. Int I is equal to 0, I less than and I plus plus. If current weight plus ARR I dot weight is less than equal to W, current weight is 0 initially plus ARR I dot weight. So ARR I dot weight means your ARRI is a structure, and inside that the weight of that item is less than equal to the weight, then current weight plus is equal to ARI dot weight. So you are adding to the current weight this weight, right? And final value plus is equal to ARRI dot value. So you are adding the value in the final value variable here, right? Else in remain is equal to, and if your current weight is not less than equal to the weight, then the remaining weight will be W minus current weight, right? Final value plus is equal to ARRI dot value divided by ARRI weight into double remain, and then you are breaking from the loop. If you come here, then you are breaking your remaining weight, right? Otherwise, you are putting the weight inside the and calculating the weight and the final value, and then they are returning the value. So your n is 3, your number of items are 3, so here 3 will be passed. Then weight is equal total weight, that means the final weight, that is W, I think is 50, and int ARRN. So item ARRN, item is your structure variable, structure and name, and for that you have created an ARR array, and n are the number of uh, items in the array. So this way they have added the items 100 comma 20, which will be your value and weight, right? 60 comma 10, 120 comma 30, value and weight. They have created the class object, solution obj object they have created. Now double answer. So a variable answer has been created, which is equal to object dot fractional knapsack. They are calling the function in the class to the object fractional knapsack. Weight ARR n. So weight is passed here, which is W. ARR is passed here, right? And n, that is number of item 3, is passed there. So see out the maximum value is. So they have set the precision. Set precision is also used in C++ for setting the precision of decimal values, which is 2. So you are printing fixed and answer. A 240 it is coming. Right? So this is the way. I don't know this sort algorithm they have not given what this sort algorithm where they have defined the function for sorting. If that is there, right? So this way you can do. This is the actual implementation they have given you, so you can do it like that, right? So any implementation can be applied to that. I don't know whether this one can be copied and run. I'm just trying. Just giving the maximum value is 240. So I think that there is an inbuilt function for already for sorting. I think there is an inbuilt function then. Right. So this is the implementation in C for fractional knapsack. So this was your. So you have this question number 1, 2, and 3. So anyone you can try for implementation. That is there. Then the next session says task scheduling algorithm. Now, task scheduling problem is formulated as an optimization problem which need to be determine the set of tasks from the given task that can be accomplished within their deadlines along with their order of scheduling such that profit is maximum. Again, this is another greedy approach where we need to maximize the profit and we have to accomplish the tasks in the given deadline and or their or order of scheduling, and we have to maximize the profit according to that. So that is our thing. So here they are saying test the algorithm on different problem instances, differentiate between a brute force approach and an efficient task scheduling algorithms. So if we go for task scheduling, I don't know I have that or not. Hmm. So if we're talking of task scheduling algorithm, so here they are saying consider task 1 to n with running times of t1, t2, tn. What is the best way to schedule them in order to maximize the completion time? So they are saying you have to maximize the completion time. So consider the problem stated as ti pairs 1, 15, 2, 8, 3, 3, 4, 10. So the brute force solution way to solve this problem is to consider all the possible ways to schedule them. Consider the completion time for each possibility. That means task number one completes in 15 now seconds or 15 minutes, whatever it may be. Second task completes in 8. Third task completes in 3. Fourth task completes in 10. Right, this is your problem. Now the brute force way to solve this problem is to consider all the possible ways to schedule them, compute the completion time for each possibility and determine the minimum one. Given n tasks, there are n factorial ways to schedule them, hence the time complexity is n factorial. Right, for above example there are 24 ways to schedule them. Right, so you have 1, 2, 3, 4. You can schedule 1, 2, 3, 4, 1, 2, 3, 4 as it is. It will be 15, 8, 3, 10. Right? You can schedule 1, 2, 4, 3, 1, 3, 2, 4, whatever. Right? There are four tasks. So 4 factorial will be 24 ways. Right? So that these combinations they are talking about, there are many combinations. Right? So now what the in the brute force implementation, if we are taking a suppose a schedule uh, function, so we are passing the different task. If n is equal to 0, then we are returning because no task is there. Otherwise, for I is equal to 1, I less than equal to n, I plus plus, perform the ith sorry perform the ith task and then schedule task 1, I minus 1, I plus 1 up to n. So that means what they are saying, you take the first ith, that is first task. If there are n number of tasks, so you take the first task, right? Perform means you are taking the time, whatever time is needed for that task to complete. Then the second task, then the third task, and the something like that, and you will be completing. One way is that. Right. So so each task you can have n number of times, so that you can arrange according to that. So they are just showing you that. I'm not going for that. So there are different ways of solving. They are saying the brute force way is this. So that is n factorial, which we were getting. But if we have to do it by greedy algorithm, so in the above recursive solution, we reduce the problem size of 4 to 4 subproblems, each of size 3. Solution to exactly one of these 4 subproblems ultimately led to optimal solution for the problem. Is there a way to determine which of the 4 would lead to optimal solution and eliminate the other 3 subproblems? In other words, we can make a sequence of locally optimal choices that leads to globally optimal solution. So yes, as per equation 1, if the shorter job is scheduled earlier, it reduces the overall completion time. This can be made use of in deciding which tasks to schedule. In the above example, the optimal order is 3, 2, 4, 1. So 3241, how we are talking about 3241, if we see this, third one is taking the least time 3, then second is taking next time, that is 8, 3, 8, and then 4, and then 1. 3241, right? So this is guaranteed to provide the minimum completion time. So therefore, the minimum completion time will be 4 into 3 plus 3 into 8 plus 2 into 10 plus 1 into 15. The time taken for completion of that task. Right. So 3 is the task, third is the task, and time taken is, I think, 3 only. It is written 4, but I think it is 3 only. 3 into 3. It should not be 4. Right. Then 3 into 8, which is second is 2 into 8, it should be. 2 into 8, then 4 into 10, and 1 into 15. They have changed the sequence of this, but that will be your completion time. So the algorithm for greedy solution is given below. Let T1 to n denote the time taken for each task. We first sort the task based on the time it takes to complete each of them. We iterate through the sorted array to compute the completion time. So in this kind of a thing, suppose there is greedy schedule function, and we are passing the number of tasks which are there, and we are sorting those tasks according to their time, right? Now completion time variable we are taking 0, weight we are taking equal to n. For I is equal to 1, I less than n, I plus plus, completion time plus is equal to weight into time, right? So we are multiplying the weight into time, right? Means the task, and weight means the time which it is taking for completion, and we are subtracting weight minus the total time which is there, which are the number of tasks they have set. So that is what the algorithm is showing. And sorting takes O log n, and iterating through the array n times to compute the completion time, n into O1, so On time. Hence the time complexity of this algorithm is On log n. So that is what they are showing. Uh, Now in this, for this, apply brute force approach to schedule 3 jobs, J1, J2, and J3, with service time as 5, 8, 12 respectively. The actual service time units are not relevant to the problem. Make all possible job schedules. Calculate the total time spent in jobs by the system. Find the optimal schedule total time. If there are n jobs, what would be the total number of job schedules? So if we go by the brute force, so it will be first J1 is taken, then J2, then J3. So 5, 8, and 12. 25. The total, they are saying actual service time units are not relevant to the problem. Make all the possible job schedules. So you can say J1, J2, J3, you can take. So 3 jobs are there. 3 factorial will be 6. 6 combinations. J1, J2, J3, J1, J3, J2, J1, J2, J1, J3, whatever, 6 combinations you can take, whatever will be, you can take this one first, this one second, this one third, whatever way. So the optimal total time, which will, all the 3 of them will give the same time. I think all 6 of them. Because total, find the optimal schedule total time. If there are n jobs, what would be the total number of job schedules? in your book, did we have task scheduling algorithm? So in this one, what is given here, let us see first. So so some of the examples to understand the greedy technique they have given here. The problem, we are not talking about them. Relation of greedy technique. So here they are saying to illustrate the same, consider a list of jobs. So these are your jobs J1, J2, J3, J4, J5, and these are the time required. In this problem, second row represent the time taken to accomplish the corresponding job. The problem is to count maximum number of jobs that are possible in the given time limit t is equal to 6. So they have given you the time limit. In this question, they have given you the time limit. In our practical one, no time limit is given. So there is the time limit is 6. So these are your jobs, right? And so n is 5. Total number of jobs are 5, right? So the select the task that has minimum time. So according to the greedy technique, we will do. They are taking the minimum time. So first job which will be completed will be J3, which is taking one as a minimum, right? This solution is feasible according to the problem because your time limit is 6, so it is under your time limit. So one is there. You have selected in S J3, and your time remaining after 1 second is you are left with 5, right, from the 6. Now the remaining second remaining is J4, right? So next is J4. So you will remove J3 from here. You will remove J3 from here from the task, and the leftmost task are J1, J2, J4, J5. And from the remaining, now the second minimum is J4. So you will select J4. It is under your, it is feasible to fit in. So 5 minus how much? 2 will, the remaining time is 3. So your set is now J3, J4. Now you will remove J4 also. The remaining one is J1, J2, and J5. From that, J1 is selected. 3 is the limit, and J1 has 3 only the minimum time, so it is feasible. So you are putting J1. Now the remaining time becomes 0. Right now you cannot put J2 and J5 in your set. So your final set, which is there, is J3, J4, J1. The final one which is there, which you can complete in time 6, is J3, J4, and J1. This is what they have given. I'm just seeing the task scheduling algorithm. What they have given is, so a task scheduling problem is formulated as an optimization problem in your case. So a brute force approach would be to generate all subsets S of given set of tasks, examine completion of each job in every subset by a deadline, calculate the profit among all feasible subset, and find the feasible solution. To calculate S, the feasible solution pi for of each task I in S needs to be summed up. There would be multiple subsets of task S. An optimal solution to the problem is one which gives the maximum profit value. Okay. So the pseudocode of task scheduling problem is list of tasks T1 up to list of deadlines defined with each task, list of profit associated with each task. Sort the given set of tasks according to profit associated with each task. Make n unfilled time slots where n corresponds to highest deadline. Right. Perform the following steps for each task by considering task in decreasing order. Find an empty time slot which is closest and not missing the deadline of the considered task. Mark the identified slot as filled. If no such slot is found, then ignore the task. So let us consider an example to understand. Suppose there are 5 tasks and each task has associated profit in rupees. The amount of time required to complete his task is 1 hour. However, the deadline of each task is given here. So if you see here, task T1, T2, T3, T4, T5, five tasks are there. Profit of that task and deadline of that task is given, right? To solve this problem, consider the highest deadline. So the highest deadline is T3, T5, right? And prepare that many number of slots of unit time to schedule the task. This will help in scheduling the task easily, as there will be no task to be completed after the highest deadline. According to the problem, the highest deadline is 3. So there will be 3 slots as illustrated in figure 4. Each slot of time unit. So they are saying that the highest deadline is 3. So 0, 1, 2, 3. 3 slots have or list of slots of a schedule to schedule a task they have given. So these are there. Now a greedy approach has to select the set of 3 tasks and schedule them in such a way that the total profit is maximum on their completion. For this, the selection criteria will be to select the task with highest profit. Right. So highest profit. So which one is having the highest profit is T2, 22. Right. So according to the criteria, task T2 is selected and place it in the slot closest to the deadline. That is, so they are saying the maximum deadline is 3. The maximum the deadline it is 3. So we have put 3 slots and we will select those tasks according to the maximum deadline which is having the maximum profit. So we are selecting T2 and place it in the slot closest to its deadline. So T2 is completing in 2. Where should we keep T2? Closest to the second one, this, right, in the 3 slots. So then T2 is selected and place it in the slot closest to its deadline, that is 1 to 2. So in 1 to 2 we are keeping the slot for T2. Next profit is T1, 18, which is again 2, right? So again the slot is 1 to 2 for that, for T1 also, but we have already scheduled it for T2. So look for an empty slot before this slot. So the slot is 0, 1 slot is empty. So task T1 is placed in slot 0, 1. Now the next task with highest profit is T4. So T4 is the next task which with the highest profit, that is 7, right? The appropriate slot for T4 is 0 to 1 because it is 1 here. So it is 0 to 1 according to its deadline. However, this slot is already filled and there is no other slot before 0, 1. So this task is not scheduled. Next task is T5 is selected and placed in the 2 to 3 slot as its deadline is of 3. Now the remaining task T3 having deadline 3, but there are no empty slot available. So this task is discarded. So the schedule is T1, T2, T4, which will be completed. Instead of T4, it will be T5, I think. It is T5, not T this. And T5 has a profit of 6. So something like that they are talking about. Now in general, there will be maximum n slots for scheduling n tasks. To search each task will explore around n slot. Therefore, time complexity is O(n) square. Now they are for I is equal to 0, I less than n, I plus plus for j is equal to j. They will. So there are n number of tasks and there are n number of slots, right? Search empty slot for ith task. Remove the jth slot from the list of empty slots. This is what you will be doing according to the algorithm, right? But I don't know whether there is any. So the problem given here, according to this, is n given n events with their starting and ending times. Find a schedule that includes as many events as possible. It is not possible to select an event partially. So you have ABCD. Events means task. Starting time is this, ending time is this. So they have given you starting and ending time. In this case, the maximum number of events is 2. As selected events B and D are as follows. The maximum number of events are 2. It is possible to invent special VD algorithm for this problem. Why they have selected B and D is the maximum profit. They have not given according to the first idea is to select an short event as possible. In the example, this algorithm selects the following events. Short event, so start time 1, end time 3. The shortest is A, right? Then A and D. A and D both the difference is 2. 3 minus 1 is 2, 8 minus 6 is 2. Right. The first idea is to select as short events as possible. In the example, this algorithm selects the following event A and D. However, selecting short events is not always a correct strategy. For example, the algorithm fails in the below case. In short, if short event is selected, it can only select one event. However, it would be possible to select both long events. Another idea is to always select the next possible event that begins as early as possible. This algorithm selects the following events. So, which is as early as possible. However, given a counter example for this algorithm, this algorithm only selects one event. The first event is selected, it is not possible to select any other events. However, it would be possible to select the other two events. The third idea is to always select the next possible event that ends as early as possible. Not giving a okay. We'll go for this one job sequencing problem. Given two arrays, deadline and profit, where the index of deadline represents as job ID and deadline I denotes the deadline of that job, and profit I represents profit of doing ith job. Each job takes exactly 1 unit of time to complete, and only one job can be scheduled at a time. A job earns its corresponding profit only if it is completed within its deadline. So the objective is to maximize the profit that can be obtained by scheduling the job optimally. The total number of jobs completed to achieve this maximum profit. So if we are inputting this deadline array and profit array, right? So according to this, the maximum profit is this one 30. So this, sorry, 40. So this one 40, then 30. So there will be a completion deadline. So here we first select first job and third job. They are saying they are selecting the first job and the third job. All jobs except first have a deadline of 1. Thus, only one of these can be selected along with the first job with the total profit gain of this. So they are saying all other jobs have a deadline of 1, and this is the first job has deadline of 4. So from one, all the other jobs which are having one, we can select one job, any one which has completion time of one, and the other job which is left is the first job which is having different deadlines. So four. So we select the first job, and the from all the other jobs which are having deadline is one, we'll select which is having the maximum profit, that is 40. So we'll select the third job and the first job. That's why the maximum profit comes out to be 60. Right, that this is what they are saying. Now if you have a deadline of 21211, and the profits are given here. Now according to this, you have two jobs having time limit of 2, and three jobs having time limit of 1. Right. So if we select from two and two, first and third have a deadline of 2. From first and third, the maximum profit is 100. So we select the first one. So we'll take 2 as the job which is having the maximum profit 100 from these two. Then the leftovers 111, we'll select any one with the maximum profit. We select, okay. So they are saying both the jobs with the deadline of 2 is having the maximum associated profit. So these two will be completed with the total profit gain of 100 plus 27. So they are saying we will choose the choose one only, will not choose the one, because this will give the maximum profit. That is what they are talking about. So in the greedy approach, first, store jobs as pairs of profit and deadline. Since we need to prioritize job with higher profit, we pair the profit and deadline together. So, sort jobs based on profit. We sort the job array in a descending order of profit so that we prioritize scheduling the most profitable job first. Create a slot array. We create slot array of size n equal to the number of jobs. Initialize with zeros. This array will help track which time slots are occupied. Iterate over each job and try to schedule it. For each job, check if it can be placed in an available time slot. This job should be scheduled as late as possible, but before its deadline. So, if an empty slot is found, schedule the job there, increment the job count, and add its profit to the total. After processing all jobs, return the number of jobs completed and the total profit earned. So this is what they have done. Again, here, if we talk, if we are taking the Python way, so this is dev job sequences, deadline, profit. These are the two parameters we are passing here. N is equal to length of deadline we are taking out. So deadline is a list of jobs deadlines, and profit is the list of profits of the jobs. So this is what we have initialized, which we have passed here to the function. So n is equal to length of deadline. So length of how many jobs are there, it will calculate the n. Then count the total job count, which is so count is equal to 0, variable we have taken, total profit equal to 0, another variable we have taken. Now jobs equal to sorted actually you can apply a function, inbuilt function in Python, sorted, which will sort these list items, right? So here if you are saying sorted, zip profit comma deadline, zip they are taking uh, zip is another function which helps you to take two lists here, profit and deadline, and it will get sorted. So profit and deadline, the two lists you have taken, comma reverse is equal to true means if you are not giving reverse is equal to true and you are saying sorted, so it will sort the arrays in uh, uh, ascending order, but you need to sort it in descending order, the maximum according to the maximum profit, and the deadline and profit according to that. It will the jobs will also be sorted according to that. So that is why zip is used. So it will be sorted in reverse order, that means descending order. So your maximum profit will be it will be put in the jobs will be a list of items having the sorted values. Now slot is equal to 0 into n array to check time slots for job. So 0 into n. So 0 square bracket 0 means this will be an array into n for I in range n. So range function is there which will be taking from 0 to n minus 1. Start is equal to min n comma job I minus 1. So in this job, I what you are saying, profit and deadline, I will be this and deadline will be this 0 0. At 0 0 location, profit and deadline, whatever the values from this array will be taken, and minimum of that, min is a function. So minimum from the 5 items in this job list, five we have from the 5 items we have to select job I minus 1, right? 0 0 minus 1, that will be our start. For j in range, start minus 1 minus 1. So start to from starting point to minus 1 means from up to 0, right? Start to 0 and minus 1 means keep on decrementing, right? If slot j is equal to 0, if slot is empty, slot j is equal to 1, right? Count is equal to 1, total profit plus is equal to job I 0 and break. So you are keep on counting and incrementing, and the slot is you are keep on keeping the jobs in the slot, right? Return, count, and total profit, and you are calculating the profit also according to that. So here deadline and profit are there, and you are calling this function here. Answer this deadline and profit are passed here to this function, right? And print answer 0 and answer 1, right? So because this deadline and profit are being your answer, so second and 127 they it is passing. So if you see here 2 and 2, deadline is 2 of these jobs, and 100 plus 27 it is giving 127. Starting point you are setting to the minimum of your job items. That is what here they are talking about. Same way they have done it in here also, only the thing is we are using here vector. So actually the question according to this greedy approach should be like this. The algorithm says that first you have to find the maximum deadline value from the input set of jobs. So your maximum deadline value is 2. Is here is 4. Maximum deadline is 4. That is the maximum you have to first set the maximum deadline first from your set of input deadlines. Then step 2 is once the deadline is decided, so your deadline is 4, that is a maximum, right? A deadline. Arrange the jobs in descending order of their profits. So now you will arrange the items according to descending order. So first 100, then 80, then 60, then 40, then 20. So descending order you will arrange the jobs in descending order of their profits. Step 3 is select the job with highest profit. So if we select this job with highest profit, their time periods not exceeding the maximum deadline. So 3 is, if we select 100, so the time is 3 and the maximum deadline is 4. So this can be completed. The selected set of jobs are the output. So now 3 is there. Now, if you see the rest of the jobs, which one you are left from 4 is 1. 4 minus 3 is 1. 1 is left. Now, with other jobs can be completed. If you take the maximum, you cannot complete that. You cannot complete 80. You cannot complete 60. You can only complete this one, having deadline 1. So 100 plus 40 is 140. You will see the selected job sets are your output. So the max find, so for how they are solving it, find the maximum deadline value dm from the deadline given. So dm is equal to 4. There are maximum deadline is 4, so dm is 4. Arrange the jobs in descending order of their profit. So first this which is having 100 we are keeping, then 80, then 60. So we have arranged the jobs according to their so first job 4, then job 5, then job 2, then job 3, then job 1. So we have arranged according to their profits. Now the maximum deadline dm is 4, therefore all the tasks must end before 4. Choose the job with highest profit, right? So we are selecting J4, which is 100. It takes up 3 parts of the maximum deadline. So 3 parts are there. So we are left with 1 out of the maximum deadline 4, right? So we must have the time limit period 1. So total profit right now is 100. In step 3, the next job with the highest profit is job 580, but the time taken by job 5
Yeah,
is,
Ritika ma'am, sorry to interrupt, but
yes,
we want to know like uh, what is the main topic which you are describing as
this is greedy approach of job task scheduling or job scheduling algorithm.
job scheduling algorithm. Okay,
Yeah, task scheduling or job scheduling.
task scheduling.
Yeah, task scheduling algorithm or job scheduling algorithm. This.
Okay, so you are describing us at like a greedy algorithm.
Yes, these are greedy algorithms which are, this is the second one which we are applying this one in our session of practical task scheduling algorithm. In the
Okay, thank you.
practical, we are doing this, the second question we are doing. So like here they are saying you have to implement this. You are given these jobs with their service times or deadlines. So the maximum deadline is 10. Then from this deadline, how will you select the jobs? That is what the thing is. If you are given the job deadlines with profits like this, so the maximum deadline of this one is 5, right? Within that 5 you have to select all the jobs according to their maximum profit. So if we arrange the jobs with the maximum profit, the maximum is 60. So 5 is the maximum deadline, so we can select 60 because it is taking 1. We are left with 4 as a 4 now. Then we can select the next 50, the highest, that is 3. So 4 minus 3, we are left with 1. Now among the other jobs which are left, right, we will select that one which is completed in deadline 1, because we are left with 1. So that is 47. So our total profit will be 60 plus 50 plus 47. That is what the question is. Right, understood?
Excuse me, madam.
So yes,
Which language we have to use it for coding, madam?
you can use C++, you can use C, you can use Python, whichever you are comfortable with.
Okay, thank you. Thank you.
That is your wish.
Okay, okay.
Right. So I'm just explaining you what the algorithm, and then the implementation. If you understand C, you can implement it in C. If you can do it in Python, if you're comfortable with Python, you can do it in Python. You're comfortable with C++, you can do it in C++. Right. So now we were talking about the job. So J4 is taking 4, which exceeds the deadline by 3, therefore it cannot be added. And the next job, highest profit is J2, the time taken is 2, which also exceeds the deadline 1, therefore it cannot be added. So the next job which will be added is 1, right? So that the next job with J3, the time taken by J3 is 1, which does not exceed. So our two jobs are there. 100 and 40, 100 plus 40 will be the profit, the first job, and the second job is J3. So J4 and J3 are the jobs. So 100 plus 40 is 140. So since the maximum deadline is met, the algorithm comes to an end. Output set of jobs scheduled within the deadline is J3, J4, J3 with the maximum profit of 140. This is what the thing is. So here what they have done is they have taken type def struct jobs char ID. So they have made a structure jobs with ID, job ID, deadline, in dead and in profit. So three variables they have declared in the structure, right? Int compare constant void. They have created two pointers, A and B. Job asterisk temp is equal to job asterisk A. Okay, temp 2 profit minus temp 1 profit. So what they are doing is this jobs is your structured variable. From the structure variable, they are creating a pointer temp1. Sorry, right? They're creating a pointer temp1 and another pointer temp2, right? And it will be taking two values from the pointers from the this jobs structure, and it will be comparing that the profit of temp2 is minus the profit of temp1. It will return that. So it is comparing both the profits actually. For this is actually what they are. This function is used for sorting all the jobs according to the profit. So this is what they are doing for sorting, right? Then find minimum between the two numbers, right? Int min, int num1, int num2, return num1 is greater than num2. So if num1 is greater than num2, you will return num2, which is smaller. Otherwise you will return num1, right? So this ternary operator they have used. This is finding the minimum of between the two numbers, right? So int main, int AR, jobs is the structure, and structure array we have created ARR. Inside the structure array, the job ID is there, A. The variables we have created A. The job deadline is there, right? And job profit is there. The three things we have declared. So this we have initialized, right? Now int n is equal to size of array divided by size. So we are calculating the size of array of this, right? ARR. So how much is the size? So it will be calculated in n. Printf following is maximum profit sequence of jobs. So q sort ARR n size of jobs and compare. The compare is this function. So int result n, bool slot n, these are the two variables we are creating, right? And then for I is equal to 0, I less than and I plus plus, slot I is equal to false. So because we have selected this boolean to keep track of free time slots, so slot I is equal to false first. The first index is equal to false. For I is equal to 0, I less than and I plus plus, right? For j is equal to minimum of n, ARR I deadline minus 1, j greater than 0, greater than equal to 0, j minus minus. So we are checking, first we are setting that j is equal to minimum of from min this where is that min function, this one. We are passing the num1 and num2 according to this. So n will be the num1. So n is your how many number of jobs you have. So n is 1, 2, 3, 4, 5. N will be 5, right? So n is 5, comma arri dot deadline. So arri, okay, the first index deadline it is comparing now. So among the 5 jobs, arri dot deadline 5 is among 5 and 2. The first job deadline is 2. So among 5 and 2, which is the minimum, right? So you are finding the minimum. So 2 is minimum, 2 minus 1. So that means it is j will be starting from 1. J greater than equal to 0, j minus minus. The first job it is taking. If slot j is equal to false, so we have initialized slot I to false first. So they are saying free slot found. If slot j is equal to false, first slot is right now false. Result j is equal to I. So you will select the ith index into result j, right? And slot j is equal to true. So you have booked that slot into this. So that means the ith item will be selected here first, and you are breaking. If you have found the slot and no more slots are there, if you are breaking from this for loop, right? Then our next index you will go here again, you will set the j's index, and then again you will check whether the slot is false, right? And then again you will set the result according to that, which one you are selecting. And then again a slot is you will set to true and you will break. So it will keep on checking. If the slot is true, you will not fill in that. You will go to the next slot and see whether that is false, and then you will keep on checking that. That is what it means. And for int I is equal to 0, I less than n, I plus plus, if slot I, printf percentage c arr result I dot id. So that those jobs ID will be printed from the array, right? So here following is the maximum profit sequence of jobs C, A, and D. So the maximum slot time is 3, and from here, if we see, so A you can select the maximum, so that is 2. And C you can select. Why they have selected D? D is not, should not be there, I think. D though you cannot select, I think. And total profit they have not calculated. You should also calculate the total profit. It will be 100 plus 40, 140. So this is how they have done the problem. So there are different implementations of this is task scheduling algorithm. Now, according to this, you can put these values, these this will be your job ID, this will be your deadlines, and this will be your profits. And according to that, you will calculate the maximum total profit and the jobs which are selected according to the maximum deadline. This is your job scheduling algorithm. Right? Now, when we come to next session, which is Huffman coding algorithm. Now, we had seen in our book, Huffman coding is a greedy algorithm that is used to compare the data. Data can be sequence of characters, and each character can occur multiple times in our data, called as frequency of that character. Basically, compression is a technique to reduce the size of the data. So that is what Huffman coding does. It compresses the data. So Huffman coding compares data by 70 to 80%. Huffman algorithm checks the frequency of each data, represent those data in form of Huffman tree and build the optimal solution to represent each character as a binary string. So Huffman coding is also known as variable length coding, right? So here they are giving apply Huffman algorithm, construct an optimal binary tree code for the letters and its frequencies in the following table. So if we go to our unit, we also have Huffman code. This is your in your theory book. So if you see here, they are saying suppose we have a 100 character data file, each character having different frequency shown in figure 1, and order of character can be in any form. To transfer the data, each character will be encoded into ASCII representation without using any compression algorithm. ASCII codes take 7 bits to represent the data in a binary form. So therefore, in a message, each character takes 7 bits to represent the data, and there are 100 characters in the message. Right. So thus, a total 700 bits need to transfer a message from one source to the other. So what they are saying is, in order to there are an order of a character can be formed. So you have a sequence of characters in a data file. 100 character data file is there. Now to transfer that data, each character will be first encoded in ASCII, American Standard Code for Information Interchange. So ASCII values are there for each alphabet, right, and whatever characters, right, without any compression algorithm. So your ASCII, if it takes 7 bits, right, to represent the data in a binary form, right, therefore in a message each character takes 7 bits. So these are the 7 bits binary code for each character in ASCII. So if you have 700 characters, or 700 in 7 sorry 100 into 7 will into 7 bits will be 700 bits need to transfer a message from one source to the other source without any compression algorithm. If you don't use a compression algorithm, you require 700 bits, right? So this is also called as fixed length encoding. So this is known as fixed length encoding because you are not using any compression or any thing. Just you are sending as it is the data, and it requires 7 bits. Or each character will require 7 bits of uh, binary form. So if there are 100 characters, so 7 into 700 will be 7 into 100 will be 700, right? So that is there. So in case the above message is sent without applying any compression, you will have to transfer 700 bits. In the above example, we are not using all English alphabets and symbols. We are just using some of the symbols we have used. Just an example. So so what they are saying is, suppose A character is there, and total bits divided by the number of times the character comes in the message is 70 times. B comes 2 times, C comes 5 times, D comes 13 times, E 3 times, F 7 times in the message. Just an example they are taking. So do we really need, so English, we are using only 6 alphabets in the message. Do we really need 7 bits to represent the data? Not really. Only few bits are sufficient to represent the data. So can we use less bits to represent the data? Because we are using only 6 alphabets, 1, 2, 3, 4, 5, 6. 6 alphabets are used in this message. So do we need 7 bits to represent this data? So they are saying not really. We can represent it in less bit also. So yes, then how many bits are needed to represent the data? As we know, we can represent 128 characters with 7 bits. 2 to the power 7 is 128. So 128 characters can be represented with the 7-bit code. So we have only 6 characters. We need definitely lesser than 7 bits. But how many bits are really needed? So let us see if we have only then only 2 characters can be represented. So 1 bit is required, 0 and 1, right? 0 or 1 you can represent, right? The only 4 characters can be represented. So you have 0001, 1011. If you say 8 characters can be represented with 3 bits, 000, so these are the 8 characters which can be represented with 3 bits, right? So 6, we have 6 characters. So which one we will use? 1 bit, 2 bit, or 3 bits? We will use 3 bits because within from the 8 characters, the 6 fits in this one, right? So shows the table corresponding 3-bit binary representation. So if we say A is 000, B is 001, C is 010, D is 011, E is 100, F is 101. If AB, these 6 characters, we represent the first 6 bits, right? So the first 6 bits we are representing as the 6 characters which we are getting from the character code. Now, how many times the character is coming, the frequency is given. So what you will do is, now you have 3 bits. So 3 into 70, 3 into 2, 3 into 5, 3 into 13, 3 into 3, 3 into 7, it comes out to be around 300 bits. So from 700 bit, which need to be transferred earlier, we have compressed it to 300 bits. So the above method requires 3 bits only to encode each character of the message having 100 characters and take 300 bits to encode the entire message. Can we do better? Let us look at the appropriate algorithm. So they are talking about Huffman coding algorithm, which is also known as variable length encoding, right? So Huffman encoding says we don't need to take fixed size code for each character. So here we were taking fixed size, 3 bits. So Huffman says that you don't need to take fixed size code for each character. In a message, some characters may be appearing less number of times and some may be appearing more number of times. So if you give a small size of code for the more frequent occurrence of characters, then the size of the entire message will be definitely reduced. So Huffman invented a greedy algorithm that finds an optimal prefix code called a Huffman code. If there is an encoding of message at sender end, there must be encoding at receiver end to read the message. So in Huffman coding, prefix codes, which is one type of variable length encoding scheme, are assigned to each character in such a way that no code for one character constitutes the beginning of another code. For example, if 10 is a code for A, then 101 cannot be code for B. Therefore, while decoding the encoded the message, Huffman coding ensures that there must be no ambiguity in prefix code assigned to each character. So, the main advantage of prefix code is that it simplifies decoding of the message. So, some more example of prefix code is set binary sequence P such that no sequence in P is a prefix of any other sequence in P. So if P is equal to 0, 1, 0, 1, 0, 1, 0, our binary sequence or code, in the code we can see that 0, 1 is a prefix of 0, 1, 0 sequence. Therefore, this particular set is not a prefix code. So if you see here, you 0 here is 0, 1, first code is 0, 1, then you have 0, 1 again, and that it is kind of a prefix and you have 0 at the end. So this code cannot be taken as a prefix. This prefix code should not be there in your sequence. Then this one P1 01 100 101 are binary sequences. In the above, we can see that 01 is not prefix of 100 and 101 sequence. Just now remember that 01 is present in 101 sequence, but it is not a prefix. It is a postfix. Similarly, 100 is not a prefix in any other code and 101 is not a prefix in any other code as well. Therefore, this particular set of sequence is a prefix and each prefix code can be represented as a tree. So this is what we have to cater to. Such kinds of code we have to take. So now Huffman coding works in 2 ways. Build a Huffman tree. Find Huffman code for each character, right? So steps for building Huffman trees. Input is first we will input a set of m characters and each character of m element m has a frequency m frequency, right? So they are saying that m are the set of array, as suppose it is an array of characters, and small m is the a particular character with m frequency, with some frequency, that this many number of times it is occurring. Store all the characters in min priority queue using frequencies as their values. Priority queue is a data structure that allows the operation of search, min or max, insert, delete, min or max respectively. If heap is used to implement priority queue, it will take O log n time. Extract two minimum nodes x comma y from min priority queue PQ. Then replacing x and y in the queue with a new node z representing their merger. The frequency of z is computed as sum of the frequencies of x and y. The node z has x as its left child and y as its right child. Repeat step 3 and 4 until one node left in the queue, which is the root node of the Huffman tree. Return the root of the tree. So steps to find the Huffman code for each character. So first, this is what you have to do in your algorithm. You have to first take the array characters, and from that array character there will be frequency of each character, right? And then you have to set the priority queue, where minimum and maximum insert delete you can do in that priority queue. From that you will select two minimum nodes x and y from the priority queue, and then you will keep on replacing x and y in the queue with the new nodes that representing their merger. You will merge those two nodes, and you will represent it as z and compute the frequencies, that is sum of x and y. And the frequency of z will be the sum of x and y nodes, and the z has x as the left child and y as the right child, and you will keep on repeating this until you reach the root node, and root node is the answer to your thing. Now traverse the trees. So if you have to convert now each Huffman code you have to find for each character, how will you do that? Traverse the tree starting from the root node. An edge connecting to the left child node is labeled as 0 and 1 if it is connecting to the right child node. So at the left child you will put 0 in the tree, and at the right you will put 1 in the tree. Right child is 1, left child is 0. So you will keep on doing that from the root. Traverse the complete tree through the left and right child based on the assigned value. Prefix code or Huffman code for a letter is a sequence of labels on the edge connecting the root to the leaf of that for that character. That means your prefix of that particular character will be whatever will be the value 0 and 1 left and right child. Connecting them will give you the prefix for that particular character. So let us understand by example. So you have a again the characters are a b c d e f, and the frequency is given 72 5 13 3 7, right? Build a min priority queue based on the frequency, right? Initially pq contains 6 nodes, 6 letters a b c d e f. Each node represents the root